All right, so 6.6 is very similar to the last section. The only difference is now we're going to take a function and basically rotate it around an axis. So, this first part is just an example of what we did in the last section with a cross section. Okay, so cross sections, if you can remember when we had the little, let's see if I can pull this up and show you this. Well, I'm afraid to do this. Wow, that's really not in the right spot. Well, anyways, I'll go back and see if I can figure that out. But anyways, a cross section is this. It's a 3D figure, but it always has a flat base. Okay, so whatever your base is that you're building on top of was always flat. Okay, so this is going to be slightly different. We're going to take something and rotate it around it. So what kind of shape are you always going to be dealing with? What? A circle, exactly. Okay, so that's going to change just slightly. Okay, so on this example, they're basically giving you two different functions. Okay, so they have the y equals x squared, which is the top line, and then y equals negative x squared, which is the bottom line, and we've bounded it between 0 and 1. And then we're going to basically find the cross sections that are perpendicular to the x-axis. Okay. Oh, using a circular. That's important too, because we need a shape. Okay. So, the idea for this is that this black piece, I don't know if you guys can see this very well on the projector. You see the little black piece? Okay, so that's like, basically if I pulled that out and faced it towards you, it would just look like a circle. Okay, so they're going to call just a circle a disc. Okay, so you guys know what a disc looks like. Like, do you go golfing? Anybody go golfing? They have a disc that they use. So that's what you should be envisioning. That's basically what we're looking at. Okay, so who remembers what the area for a disc is? Pi r squared, right? Okay, so the key piece on this is that the r is basically going to be the distance from the x-axis to the top equation. Okay, so basically half of that whole width. Okay, so when we set this up as the integral, so the volume is going to be from 0 to 1 of pi, and then my r length is just going to be x squared. And then since my r is squared, I square x squared. And then since we have a function that's in terms of x, it'll be dx. Okay, so this example is a cross section. Okay, is everybody okay with the way that was set up? That worked? Okay. All right, so now we're going to take that exact same idea, but we're, instead of having like a lower bound function that exists in the negative direction, we're just going to use the top half as the r, because really we didn't need that bottom half. Okay, so we're going to take that parabola and revolve it around the x-axis. Okay, so here is the equation for a disk. Okay, notice that they pull the pi in front of the integral. It just makes it a little bit easier to deal with, so you don't have the pi in the middle of it. Okay, I kind of like that. Okay, so can you imagine this getting revolved around the x-axis, kind of mentally? It's kind of hard. What does it kind of create? Yeah, like a cone or like a funnel. Yeah, except for the funnel would be like filled in. Okay, so it's a solid volume of space. Okay, so to set this up, the volume for this one is going to be pi between the two x values, which is 0 and 1. And then in this case, our radius is just the height of the equation. Okay, so it's just going to be x squared squared dx. Okay, so this one is just slightly different because now you're just taking one function and revolving it around the x-axis versus the last question, which was a sectional cross-section. Okay. All right, so let's do another one and we'll kind of start from scratch here. Okay, so this time they give us this equation, which happens to be exactly the same. Okay, so notice they use the word revolving, so that's a piece of information that you're looking for when you're doing this. So like when you get to the test and you don't know if you're doing the cross-section or the revolving, that's a word, a keyword. Okay, it's going to be bounded by x equals 0 and y equals 4, and we're going about the y-axis. Okay, so let's start by graphing y equals x squared. Okay, so what is y equals x squared? They are just asking us in the first quadrant. But what does it look like? It's a parabola, right? And if I wanted to like be pretty precise in my points, it should go through exactly 1, 1 and 2, 4, right? So from 0 to 1, 1 to 2, 4. Okay, I could continue drawing it up. Wow, that's not a beautiful drawing, but that'll work. Okay, x equals 0. Which line is x equals 0? The y-axis, good. So we're bounding it there. And then which line is y equals 4? That would be like a horizontal line up 4 units, right? Okay. So you see this region that is bounded. Okay. And this time we're going to revolve it around the y-axis. So we're basically having this vertical revolve. Okay. So it's again making that kind of I don't know what that shape is. Cone-ish shape. Okay. All right, so to set this one up, are we going to do this one in terms of x or y? In terms of y. Good, because we're using the y-axis to revolve. Okay, so the first thing that I need to do is I need to take my equation, this y is equal to x squared, and I need to rewrite it so that it's set equal to x, and in terms of y. So how would you solve that for x? Square root it. So x would just be the square root of y, and I don't need a plus or minus version, I only need that right-hand side, so that right-hand equation is the same as the square root of y. Okay, so now I'm ready to set up my integral. Okay, so it's going to be pi, and between what two y values are we going? 0 to 4, good, so from 0 to 4, and then I just need my radius. What is my radius length? The square root of y, and then that would be squared because it's pi r squared, okay, dy. Yeah. Okay, and it did ask us to find it, so we're actually going to complete this integral. Okay, so really quickly I can say that the square root of y squared is really just the same as y, right? So I can integrate y, that's pretty simple. What's the integral of y? 1/2 y squared, good. So we're going from 4 to 0. Okay, so then I'm just going to plug in the big one minus the little one. So I have pi times 1/2, and I'm going to insert 4 into my y. And what happens when I put 0 into my y? What would I get out? 0. So I'm not going to say minus 0 if everybody's okay with that. Okay. So then if I simplify that, I have 4 squared, so that's 16, and half of 16 is 8. So we get an area of 8 pi. Or I should say a volume, excuse me, not area. Everybody okay with that one? Pretty easy? Okay, so this one is, I don't know, I kind of think this is almost easier than the last section. Because you know your area formula is pi r squared every time. So it's a little bit simpler. Okay, on the next section, what they do is they introduce this idea of a washer. Okay, so you guys know what a washer looks like? All of you construction people? Basically, it's a disc with a hole in it. Okay, So if I was going to find the area of a washer, I would need to know the radius of the big length, the big circle, and I'm going to call that a big R. And then I would need to know the radius of the little circle, which I would call little r, and then you would just simply subtract them, right? Okay, so that's where they get this formula right here that's highlighted. Okay, so you always do big R squared minus little r squared. Okay, so this, let's see if I can pull this up and show you what this washer kind of looks like. It might take 5 hours, so maybe I'll come back to it after it's loaded. It's really slow on the tablet. Oh, wait for it. Okay, I'll come. What? Maybe. Okay, I'll come back to it. It's a little bit slow. Okay, so the first 3 examples here are basically using the exact same equation, but they're going to revolve around different things. Okay, so the first thing is that you really need to decide if you're using the disk formula or the washer formula. In the first 3, they tell you, which is very nice of them. Okay, so for A, we have the bounded region of the negative x squared plus x, and y equals 0. So you can see that bounded, beautiful blue area. Okay, and we're going around the x-axis. Okay, so we can probably go straight to our setup here. The volume is going to be, oops, pi times the integral between which 2 x values? 0 and 1. And then what is my radius for this one? Yeah, negative x squared plus x. And I need to make sure to square it and then say dx. Pretty easy. So just setting up. That's the nice thing about this assignment is they kind of just have you set things up. Okay, I want to see if this is done yet. Nope. Okay. For B, this time they're going to go about y equals negative 1. Okay, so that's going to be a horizontal line that's down 1 unit. Okay, so this time it's going to create a washer because you have a space between the line that you're revolving around. Okay, so we're going to need to figure out what the big R is and what the little r is. Okay, so the big R is from the red line to the top of the parabola. Okay, what is that length? What is my big R? Negative x squared plus x plus, what is the distance between the x-axis and the y equals negative 1? Plus 1. Yeah. Okay, so you can write this as negative x squared plus x plus 1, or you could put the 1 in front. Either way. Okay.
So why is it plus 1?
It's plus 1 because there is a distance. So the distance between the x-axis and the parabola is just negative x squared plus x. But since we also have the distance between the x-axis and the y equals negative 1 line, that's a distance of 1. So we have to add that in. Okay, so what is my little r? What is the distance between the x-axis and the y equals negative 1 line? 1. Okay, so now I can just use my washer volume formula. So it's just going to be pi times the integral between our 2 x values, same as it was before, 0 and 1. And it's going to go r squared minus, or big R squared minus little r squared. So it'll just be negative x squared plus x plus 1 squared minus 1 squared dx. Does everybody follow that one? So they make it a little bit more complicated when they go around different axes or different lines. Okay, see if my thing is done yet. Still not done. All right. I'm going to give an example at some point today, hopefully. Okay, so see, this time they're revolving it around the y equals 2 axis. Okay, so it's up higher there. Okay, so this one is going to be a washer again. Okay, so we first need to find the big R. The big distance is going to be between the y equals 2 and the x-axis. Okay, so what is the big R length? 2, and it's always 2. It doesn't change. It's a constant. Okay, the little r is going to be the distance between the y equals 2 line and the parabola. So what is my little r going to be? 2 minus. Very good. So does everybody see how it's 2 minus that equation? Does that make sense to everybody? Because you have a distance of 2 and you're going to subtract out the height of the parabola. Everybody's good with that? Perfect. All right, so my volume is going to be pi times the integral from 0 to 1 of my big R squared, so 2 squared, minus my little r squared, 2. And I'm going to go ahead and distribute the negative through because it just makes me feel better to have a little bit less parentheses involved. So I'm going to say plus x squared minus x and square that dx. You don't have to, though, if we're just setting up. Good there? That was pretty easy. Okay, so now they do basically the same thing, but now they use another function. Okay, and they don't tell you specifically if this is a disk or a washer, so you have to kind of figure that out. Okay, so we have this orange region that's going to be revolved around the x-axis. Okay, so are we doing this in terms of a dx or a dy? Dx, good. So around the x-axis, we're doing a dx. Okay, let's see, where do I want to go with it? Let's do big R first. Okay, so big R is going to go from the straight line down to the x-axis. What's that? Oh, sorry, I guess I should ask that question first. Okay, so if I take this thing and revolve it around the x-axis, do you see how there is a space between the lower axis? Like if I'm looking at this sliver right here, specifically, there is a space between the axis that I'm revolving around and the bottom function. So that's how I know it's a washer. Right. If this was completely filled in all the way to the x-axis, then that would be a disk. Right. Yeah, right. So for it to be a disk, it would have to be touching it the whole way underneath. Okay, so what is the length of my big R? Okay, so the big R goes up to the straight line. What's the equation of the straight line? X plus 2, good. Okay, and then my little r goes from the x-axis to the parabola. Okay, so what's the length of my little r? What? Just x squared, right? Okay, so now when I go to do my integral, I need to know which two x values I'm going between. Is it fair to just say I'm going from, it looks like -1 to 2? Can I just say that the graph is hopefully drawn to scale and go with that? Yeah, I probably wouldn't personally. So I'm going to just verify that it truly is. I would probably never assume that a graph is drawn to scale. Just in the history of all drawings that I've ever seen, usually they're not drawn to scale. Although this one looks pretty good. I'm just going to verify this. So I'm going to set this equal to 0. Okay, and I can factor this. The two numbers that multiply to -2 and add to -1 are -2 and +1. So I do in fact get +2 and -1. So the graph looks like it is and truly to scale. All right, so my integral for volume is going to be pi times the integral from -1 to 2. And I'm going to go big R squared, so x plus 2 minus little r squared dx. Everybody okay on that one? That makes sense? Okay. All right, so here is our last one. Okay, so this time we're going about the y equals 4 line. So let's draw that on here. So we got this line right here. Okay, so they kind of give you a little example of the disk where it might lie. Okay, so is this going to be a disk or a washer? It touches, but it's not completely filled in. There is a gap, like specifically right where that little example lies. Okay, so this is a washer. There is a gap. Okay, so I'm going to do a big R. Okay, so my big R is going to go from my y equals 4 line down to my parabola. So what is the distance from the y equals 4 line to the parabola? 4 minus x squared. Good, everybody okay with that? Because we have a height of 4, but we're going to subtract out the height of the parabola. Okay, and then my little r goes from the y equals 4 line to the straight line. So what's that distance? 4 minus the quantity of x plus 2. Good. Make sure you have parentheses there, or you distribute your negative. How come I didn't do minus on the first? Which first are we looking at? You're good? Okay. So I guess I probably should have asked this earlier. Are we doing this in terms of, is this a dx or a dy? If we're going around the y equals 4. No? Because it's perpendicular. So it's in terms of x, it's a dx. So we can still use our same bounds that we found on the question right before it for our integral. So it'll go from -1 to 2. We're going to go big R squared minus little r. And I'm going to distribute that. Probably could simplify it too, but eh.
They don't give you like a sliver, so how do you know where it is?
They don't give you a what?
They don't give you like the marked area, so how do you know where you're, if it was a disk or...
Okay, so you see how you're going around the y-axis, right? Okay, so you can pick any sliver you want out of that area. Okay, so if you pick any of the slivers, doesn't matter which sliver you pick, there's going to be a sliver that has a gap between your little sliver and the y-axis. So it's going to create a washer. Okay, so the difference in that is like, do you see how in question 1a, that one is a disk? See how that whole area is up against the thing that you're revolving around? So that one is revolving around the x-axis. That the whole area touches that. Does that make sense how the difference is? Okay. Well, that's unfortunate. Okay, I'll pull that up on my computer and show you guys this, because I think it's kind of cool. All right, so that's it. So you guys have to do, for your problems, oh, I didn't write it on the board up there. You have to do 1 through 10, and then also 15 through 18. Okay.